And it's the top of the hour. We'll probably get going here in just another minute. I'd first and foremost, I'd like to thank Nathan and Jim for working with me to put together this unofficial series of joint community of practice sessions with AI and DevOps. It's been a lot of fun with USDA, NASA, and today it's going to be GSA sharing their efforts. I just put it out to y'all as you're listening. If there's any other activities that would like to present on what they're doing relative to RPA, AI, and how DevOps is enabling that, let Jim and I know. We'd love to give you an opportunity to speak and share across the federal government. So, and also thanks to Krista and Joe. But yeah, let's go ahead and kick off here. It's a minute after. Folks will probably continue to join as we get going. But good morning, everyone, and welcome to our third cross-community event that's sponsored by both the DevOps and RPA communities of practice. Again, it's been fun hosting USDA and NASA in previous weeks. I'm really looking forward to GSA today. I'm Brian Fox. I co-lead the DevOps community of practice, and I'm joined by Jim Gohagan and Nathan Keene, who support the RPA COP. Today, we'll be hearing an overview of GSA's AI Center of Excellence, where our presenters will discuss their current processes, how they got there, and lessons learned along the way. Our goal with this is to share how organizations are implementing innovation, and in this case, AI, RPA, and DevOps. So really the goal is sharing. We've seen in the past that folks want to meet individually with presenters, typically after the event, in order to have a deeper dive into the specific technical topics. Feel free to reach out to either Jim or I, or even Nathan, to have those kinds of introductions with the presenters. We're happy to do it, and we believe it's a natural outcome of this kind of event. Krista and Joe today, they're not going to get into every detail that you might be interested in. I think we're going to go about a half hour, maybe 45 minutes today. So if you want to follow up to deep dive with them, please reach out to us. Otherwise, thank you all for being here today, and thanks for the energy you bring to our events. We'll be recording this event, and so giving you all the opportunity to share the information with colleagues afterwards. If there is an issue with Zoom today, we'll record and share with you all later. With that, I'm going to turn it over to Jim, who's going to run over some housekeeping and introduce the speakers today. Jim, over to you.
Thank you, Brian, and good morning, everyone. And so as you can see on the screen there, we do have all our participants muted today. That'll allow our speakers to present without interruption. However, we do encourage you to submit your questions at any time via the chat box in Zoom, and we'll make sure to leave plenty of time at the end of our presentation to address those questions. And in addition, as Brian mentioned, one last reminder that today's session will be recorded. So with that, I'd like to move into introductions, and we are grateful to have two highly accomplished experts from GSA's Technology Transformation Service, the Center of Excellence. We have Krista Kinnard with over 10 years of experience in the public and private sector. Kinnard leads her expertise in leading artificial intelligence teams, combined with her time as a data scientist, gives her the unique ability to bring together technical and business minds to drive innovation in the government space. At the AI CoE, Kinnard empowers government agencies to bring artificial intelligence solutions into practice through the development and enhancement of AI infrastructure and governance workforce development strategy, and AI program and project management. Welcome, Krista, and thank you. Joseph Raetano is a highly trained veteran naval officer and Department of Energy researcher with R&D innovation experience. Raetano has been consistently selected and trusted throughout his career to develop successful special technical programs. He has over 3 years of experience developing new programs in AI ML and over 15 years of offensive and defensive cyberspace R&D testing and operations experience. His skills have been utilized in concept development that set cyber vision, strategy, and implementation at the national and service level. He also has over 10 years of experience of explosive ordnance disposal experience. Raetano's career is supported by an MS computer science and PhD candidacy in computer science focusing on edge artificial intelligence. And I dare say, looking forward to some explosive and fun remarks, insightful remarks from Joe. So thank you both for being here today. Yesterday, TTS held an Impact Summit, which featured speakers from across the federal government. It was a really exciting opportunity to learn about technology modernization efforts happening across the federal government and the impressive work that Krista and Joe lead. We're fortunate to have them here today to introduce these 3 community practices and highlighting some ways in which they overlap. So with that, I will turn it over to Krista and Joe to begin the presentation.
Thank you so much, Jim and Brian, for the introduction. We're really pleased to be here. I want to talk a little bit about the agenda because we've got it laid out for you, but I would like this to be a little bit more of a conversation. So I would also like to say part of what I do as with the Centers of Excellence is I actually work really closely with Steve Babbage, who runs our overall TTS AI portfolio, and really importantly for this group, our AI community of practice. So I've been very involved, and Joe has also been very involved in our AI community of practice. So what we've got here, we've got a lot of buzzwords, right? We've got AI, we've got RPA, we've got DevOps. And there really is some meat behind those, right? They're not just words. And I think that's why these communities exist. And I think that we all approach these different topics through a different lens. So what Joe and I are gonna do is we're gonna run through some slides, but we're gonna invite Jim and Brian to jump in as we're speaking, wearing their different hats, right? So Joe and I, we're deeply involved in artificial intelligence, and that's really our bread and butter. And I know when Brian looks at this, he's not wearing an AI hat, right? He's wearing his DevOps hat, thinking, all right, how does this work in our DevOps community? How do we think about this in kind of the regular and how we're working with our software development cycle? And so he's gonna see it through a different lens. And so I really want him to jump in through that lens. And I know, Jim, right, with your RPA experience and what you guys have been doing in your community, you've also got a little bit different approach to how you think about that. And that's great. So there are slides. This isn't going to be me and Joe reading a bunch of slides to you. I'd really like it to be a conversation. And we'd also really like to hear from you guys. And by hear from you, I mean, please put your comments and your questions in the chat, and we'll get to those at the end. So that's just kind of some level setting of what we're going to be doing. So first and foremost, what we're going to do is we're just going to talk about what do we really mean when we say AI and machine learning, and what does that life cycle look like, right? What does it take to build an AI solution? Because though it is software, it's a little bit different than traditional software development. And then we're going to jump into, right, DevOps and DevSecOps, and how do you start plugging AI development into that life cycle? And so we're going to talk about what does building that full development stack look like to be able to be doing your artificial intelligence development through DevOps and DevSecOps. We're going to talk a little bit about the AI sustainment cycle. And then we're really going to bring it all together, right? Because what we're going towards here is automation, right? And using these technologies to really enable agencies to meet their mission, right? So how do these 3 things play together to really get us to that point of how can we start doing some intelligent automation? So we can go ahead and get started on the next slide. So what really is artificial intelligence? I know Joe and I both, we laugh about this a lot, but I can't tell you how many people have asked me when I tell them that I work at the AI Center of Excellence. They say, oh, so you're building Skynet, right? No, I hate to disappoint, or actually I think it's probably a good thing that we're not building Skynet, but we're not building Skynet, right? I think that there's a lot of hype and a lot of misconception and a lot of aggrandizing of AI and what it's capable of. So I just kind of want to dispel a little bit of what are we really talking about when we say we're working on building AI within the federal government. So the first thing is, right, there are things that people are good at and there are things that machines are good at. We're not trying to use artificial intelligence to replace the things that people are good at. In fact, many of the things on this list, like creativity and compassion and morals, those are not things we will ever be able to program, right? That is something that will always require that human touch. But there are things that machines can help us out with, like processing data and extracting meaning and bringing together disparate data sources to help provide impact, right? So what we are really talking about here with artificial intelligence is, you can see on the left, we've got this embedded diagram. Really what the intelligence is coming from is the ability to learn from a corpus of data, which is different than traditional rule-based logic, right? So that is where we're getting into this realm of machine learning, right? Algorithmic thinking, algorithmic-based programming that isn't if this, then that. You see this, do that, right? You're looking at a corpus of data and you're saying, all right, let's build an algorithm based on the unique features of this data to help inform decision-making. And that's where the intelligence comes from, right? The intelligence comes from that ability to learn. So that's what we're talking about. Let's go to the next slide. So how do we learn, right? How does an AI system learn? Well, really that boils down to what are the types of machine learning techniques that we can use and what are the types of algorithms that we can use. I'm not going to spend a lot of time on this slide because we could do a whole tech talk on this, but really right now where we're at in terms of artificial intelligence and machine learning technology is we've got three main types of learning. I think the easiest and probably the most familiar to folks is supervised learning. And that's where you know what you're looking for, right? So that's where you're seeing a lot of classification, right? Is it a cat? Is it not a cat? And we're going to talk about that a little bit later, right? Is it fraud? Is it not fraud? Doing some forecasting and some diagnostic. You see a lot of this actually with image recognition in the healthcare field, right? You can look at past examples of what does a tumor look like? What does a cancerous mole look like, right? And you can train it because you already know what the answer is. So then we've got unsupervised learning. And I think that the name often misleads people a little bit and they think, oh, well, that's just learning that happens on its own. Not quite. Really what we're talking about with unsupervised learning is where you don't know what you're looking for. You don't know the answer, right? You don't have that, it's a cat, it's not a cat to look to. So what you're doing with unsupervised learning is you're building an algorithm that's able to do a lot of clustering. So clustering algorithms are a really great example of unsupervised learning. And that's where you see examples like customer segmentation, targeted marketing. A lot of that's using clustering algorithms, which is unsupervised learning. You're also starting to see this, and this is kind of getting into the weeds for dimensionality reduction, right? Which is really starting to get into some complex computer science and complex math. So I'm really not going to dive into it now. If you would like to learn more about it, future Dr. Joe Raetano is happy to elaborate. And then the biggest thing, and really kind of the newest, and I think most cutting edge, is this thing called reinforcement learning. And this is, these are algorithms that are actually able to continuously learn based on a feedback loop and what's called a reward mechanism. And so that's where you're starting to, you see these a lot in like self-driving cars, right? They're using a lot of reinforcement learning. Game AI, right? That uses a lot of reinforcement learning. Things like that. Robotic navigation. So if anyone has an iRobot vacuum, or sorry, a robot vacuum, it can use a lot of reinforcement learning to learn your floor plan, things like that. So this is just kind of a brief overview of how are we learning. And this is going to be important for really the AI life cycle. So if we go on to the next slide, I think really what's of interest to this group is, all right, so sure, we can be in the weeds on what is AI, how does it work? Really, I don't care how it works unless I'm a technologist. What I care is that it can do what I want it to do, right? I want to build a system and train an algorithm to be able to get to the outcome I'm looking for, right? To help our system, to help us meet our mission, to help make more efficient a process, right? So what does that life cycle look like? I'm going to walk you through an example, and I want to go back to this cat, not cat example. It's going to be a little bit oversimplified, but I think it's going to be pretty accessible and pretty easy to kind of get the basics of what it is we're talking about, right? So let's say you want to build an algorithm that is able to identify cats in pictures. Sounds pretty simple on its head, right? Is it a cat? Is it not a cat? So in our design process, we got to be thinking, all right, are we trying to identify every single cat that ever existed in all time? Are we talking about only cats that exist now? Are we talking about cats in nature? Are we talking about cats in houses, right? Because what you are trying to identify is really going to shape what do you need to pull in as your training data to really be able to choose a model and train a model to do what you want it to do, right? You don't necessarily need to boil the ocean and train a model on every single cat that has ever walked the face of the earth. If really, you're just building something to identify cute pictures of house cats on the internet, right? So let's go with that. Let's say we just want to build an algorithm that is able to identify cute cats on the internet, right? So like mostly house cats. All right, well, so what do we need? We're gonna need a bunch of examples of cats, right? Of the cats we're trying to train on. And we're gonna have to be able to combine all those, right? And ingest them and be able to manipulate them. And that's a process called data wrangling, right? So you're gonna have to, where are you gonna store thousands and thousands of images of cats? Where are you gonna store the labels for those images, right? All of that is taken care of in your data ingestion and data management part of that. Then you actually need to get those images and their corresponding labels into a format that is consumable by a machine learning model. And that's a process called feature selection and feature engineering, right? Not every single element of the picture is going to be helpful to training your model, right? So we do a process called feature selection and feature engineering to help us pick out the things that are going to be most helpful in training that model to get us to cat. And then we got to train a model. And here's where I want to be really, really precise. And Joe, again, he experienced doing this in his research. Usually when we're talking about training a model, we're not just talking about one model, right? If we're doing this from scratch, right, we're going to say, all right, there's a couple of different types of supervised learning models that can handle image data. Let's figure out which of those is really going to be best for what our purposes are. So you're probably going to go through a couple of different rounds of experimentation, training these various models, figuring out how they're performing, and going back and saying, oh, okay, this one didn't do this one thing, but this other model performed a little bit better, right? And you got to go back through it. So what you're doing is, as you're training a model, the model is going to give you output to tell you how it's performing, right? So you're going to get, in supervised learning, you get things like true positives and false positives, right? How many times was it actually a cat? And we said it was a cat, right? That's what we care about. But we're also going to do a human check, and we're going to look at it and say, is this really doing what we want to do? And you're going to be able to see, oh, it looks like it's doing really great with cats that are standing up, but it doesn't do so well on cats that are sitting down. Or it looks like it's doing a really great job of picking up cats that are solid colors, but it's not doing a great job of picking up pictures of cats that have stripes, right? And so that's why it's this very iterative process. And this right here, this iterative nature, is why DevOps is going to be so important to the AI lifecycle, right? You have to iterate to get to a successful model. Unlike I think with traditional software, where folks are saying, you know, it's important to iterate. It's important to go back to your users. It's important to test and reevaluate. A lot of times that gets skipped, right? It is good software practice to do that. But if you don't do it, you still get software. Whereas with artificial intelligence, if you don't iterate, if you don't go through this process of testing, evaluating, monitoring, going back through, tweaking your model, you don't have AI, right? This iterative nature is what makes artificial intelligence intelligent. And it doesn't just stop in development. So eventually we're going to get to a point where we say, yep, all right, our model, it can pick out cats. It picks them out laying down. It picks them standing up. It picks them doing a cute little dance. It picks them out wearing a hat. Great. Let's deploy this. We're still not done, right? Once it gets into deployment, again, there's kind of this operations and maintenance that happens with software, but it's usually a lot less of an effort, right, that is given to that. In artificial intelligence, we still need to be monitoring that model and making sure it's actually doing what we want it to do. Model degradation and model drift are real problems with artificial intelligence. So you can't just set it out there and let it go and do its thing, expecting it will continuously do the exact same thing, right? And so that's why, again, even once you get into production, you're going to iterate. You're going to bring it back. You're going to be constantly looking at that model and its performance. And then the other side of it is, what if all of a sudden you say, all right, so we did a pretty good job of training this to identify house cats. What about zoo cats? Well, now we've just opened this up to an entirely different universe, right? Lions have a mane. I don't know about you, but I have never met a house cat that has a mane, right? That's something that maybe the model will pick up, but maybe it won't. Or what if there's a very rare Siberian white tiger, right? It looks a little different than a house cat, right? And so through a process, again, we're getting a little technical, but you can take what you learned from those house cats and augment your model and apply it in new areas. But again, you don't just magically take it from one application to another. You got to think about, all right, maybe what we're expecting is a little different. So maybe that means we have to get back into this iterative development cycle to get us where we want to go. So I'll stop talking about the life cycle there. I know I probably opened us up for a lot of technical questions. This isn't really designed to be a tech talk. So we can go on to the next slide. And I'm going to pass it over to Joe. So given what we know of the AI development life cycle and how foundationally important iteration is to the development of an AI solution, I'm going to give it to Joe to talk about how does this fit into our DevOps pipeline and what does that look like? So Joe, it's all yours.
Thanks, Krista. So we all know that DevOps is a set of practices that combines software development with IT operations. And it's that refinement process over time to achieve the goals of the organization. The key is that it's an agile software development process incorporated into your operations. So it's pretty interesting. And as you'll see in the next couple of slides, that DevOps or that agile manifesto is integrated throughout the layers that we'll be discussing. Next slide, please. So DevOps has grown a little bit in the Department of Defense arena to incorporate security. So now we have DevSecOps. So you can see they've added another layer into this DevOps or agile process. So the key is, you want to reduce that mean time to production. And you might see some interesting artifacts that come out of the DevSecOps, like your software factory and the pipelining for your environments. So you want to increase the deployment frequency, how often a new release can be deployed into the production environment. And you want to fully automate your processes to incorporate security. This is a big area, but they're adding just another layer in and incorporating that into the agile process. Next slide, please. So with robotic process automation, you're taking that automation, that traditional workflow automation, and you're starting to automate it. So, with traditional workflow automation, a software developer will produce a list of actions or interactions and automate those tasks and interface it to maybe a back-end system using internal APIs or a dedicated scripting language. So RPA comes in to help automate, help regular users to go ahead and take that action list and watch the user perform that task using the application's graphical user interface, then performing that automation by repeating those steps directly in the GUI. RPA helps to lower that barrier and that use of automation, and it's that next step, and it's a great enabling technology into the world of AI. Next slide, please. So now what you want to do is you want to customize that stack for your individual organization. Just getting to the DevOps or DevSecOps level, it's a massive challenge for some organizations, especially if they're really small, but even large ones too. You've got to wrangle different organizations, and your different models of how you accomplish that or how you stack your processes are going to be different. So we don't want to distract like the small teams to get to AI, but it's really difficult to go from 0 to AI, and that's why the DevOps community is so important to get to these next levels. So at a base level, you want to start with your people and pull together a great team. On the next level, you want to have your infrastructure set. It needs to be solid, scalable, and secure. And then you get to the DevOps piece where you're starting to streamline that evolving Frankenstein that's been created, and you have your CI/CD pipelines evolving. You add your security layer. Once you have that secure foundation, then you can start trusting your processes. You can trust your equipment. You can trust the software that you're developing. Now we're going to get into some layers that are really important past DevOps, and we start getting into the data layers, where Krista talked about. Super important because you're really not going anywhere too fast. Now you might get a chunk or a corpus of data and start working on your ML model, but it's not going to be very repeatable. It's not going to be managed very well because the data layer really takes a lot of work. And I find that in our 15 or so engagements that the data layer is where a lot of government organizations are getting stuck right now. Some have capitalized pretty well and they're really moving out on it. But for the most part, I think we're getting stuck at that layer right there. And then that goes to the next layer. Once you've sort of sorted out your data, you get into the ML engineering where you train, you validate, test, and deploy those models. Now, once you've done that, that's a lot of work to get to. You start designing your AI capability and pulling those models together because you might use 1, 2, or 20 models for your AI capability. And there you've got to actually, just like product management, you've got to manage, maintain, monitor your AI deployments. But like Krista said, there's this iterative approach, much like the DevOps community, where you need to be agile, you need to be constantly improving, watching for that model drift. Next slide.
Joe, actually on that slide, but if you don't mind me interrupting.
Yeah.
DevOps from a method and/or tooling standpoint provides this concept of iterative and some automation to deploy and test faster, especially associated with AI and machine learning. What are some of your thoughts, and Krista, yours too, as far as probably at a deeper level, philosophical level of this DevOps? And I think DevSecOps, what it really highlights is this concept of organizational integration around the product and questioning if you're not involved in product, in the generation of the product, you're not generating value. Hence the folks keep wanting to add to the acronym, breaking down the barriers. I think it's a good sign. What are your thoughts really around the people ops or the philosophy ops of that, as far as getting folks engaged and integrated that way?
Yeah, I think every organization is different. So out of the 15 engagements we have currently, and they're growing very quickly, we find that each organization is set up differently. So, what does your stack look like? So in one organization, they have a test and evaluation, or T&E section that's very big for AI to test and evaluate the artificial intelligence. They've even incorporated their ethics analysis into the T&E portion. So that organization will have their own standalone T&E stack, which they're very focused on. Other organizations might combine 2, 3, or all of these stacks all together because it's a small shop. And so the key, we look at it, especially for these large organizations like, NASA, they've been doing some great work with RPA, and they've had vendor assistants to come in and help them build out that area of expertise. And so I guess, it's one of those things where you've got, not all organizations look the same. So you've got to figure out what their goals are and then apply the stack as needed for their organization. But I love your idea about the integration of DevOps. And you can almost say that DevOps, or this agile process, might be a vertical in those steps.
Yeah, I well said, Joe. I 100% agree. What I'll add to that, Brian, is one of the biggest frustrations of my life as a data scientist is you can't just go to someone and say, here's your machine learning, right? That's not how it works. And I'm sure, Jim, you and your teams have had similar experience. You can't just go and say, well, here's your bot, peace out, right? There really is, and that's why number one, and this really the strong layer at the bottom is you gotta pull together the team, and you gotta have your team involved from the onset. That doesn't just mean your technical developers, right? That means your business owners, right? That means some of your users, right? If your users aren't bought into this, right? Doesn't matter if you build the greatest machine learning model ever. It doesn't matter if you build the greatest bot ever to do what they want. If you give it to them, like, what is this? You're just gonna tell me what to do now? Like, that's not a way to get it integrated into your environment, right? So bringing in those users early on so that they have input, right? And in our experience, right, with the COEs where we're partnering individually with agencies is, honestly, those users, they ask really good questions, right? Because they're not so down in the weeds of, oh, we got to get this bot built, we got to get this model trained, we got to hyperparam, right? They're just thinking about their workflow, right? They're thinking about, what am I going to do on a day-to-day basis, and how is this going to fit in? So they often come up with really good questions that also, when you involve your entire team early on, and honestly, even your acquisition team, right, who's going to be helping you buy this, when they understand what you're trying to go for, that makes it so much easier at the end to say, hey, we built this thing, let's make it a part of our ecosystem, right? Because you can't force change on people. People need to embrace it, and they need to be owners of it from the onset. And when they're involved in the development process, they become a more informed user in the end.
And Krista, just one follow-up question related to that, because we're talking about machine learning, but then the organizational learning that's required to not just make sense of, but make value out of machine learning and AI. You and Joe want to talk a little bit about that, as far as where organizations start, but then where they end up?
Yeah, I know Joe and I talk about this a lot, and it can sometimes be a challenge because you've got a lot of different maturity levels going on here in terms of what do you already know about what it takes to build an application, right? You've got some folks who are great computer scientists who understand traditional software, but there's a switch, right? There's a kind of a change in mindset if you're going to be building AI. You've got other technical folks who are great statisticians, right? They understand modeling really well, but maybe not necessarily the software component of it. And then you've got business owners, you've got practitioners, you've got leadership who maybe aren't techies, right? But this is still something that's going to be a part of what they need. So what they need to understand, what they need to know about machine learning is different. So my personal opinion is there's a lot of stuff out there on the internet, honestly, an overwhelming amount of things out there to teach you what you need to know about AI. I would say a really great way to learn about AI, no matter who you are, a business person, a leader, a program manager, an acquisition specialist, a statistician, a computer scientist, just start playing around. You got to try it, right? And that's how you're going to learn. You got to learn by doing. Joe, I know you've got lots of thoughts on this also.
Yeah, for sure. I think the workflow and work training to increase the level of knowledge for government. I think we can pull a page out of the cyber playbook to understand how the cyber organizations are growing and training their folks, because AI is every bit as complicated as the cyber domain. So I think we can learn a lot from the cyber accepted service. Next slide. All right, so I just want to touch quickly on data ops. And again, it's sort of this agile method where you want to have an automated process to improve the quality and reduce the cycle time of data analytics. And it's so important. And, you know, when I talk to data scientists and I just say, hey, did we get it? You know, and do we know about the data and can we use it? And they're like, well, it's a little bit more than that, Joe. Let me just tell you, right? And, you know, a lot of organizations, we just finished up a large timeline of how we helped one organization with data. And there's a large data set. They have a lot of disparate data sources. And, you know, we had to start off with a human-centered design workshop and working sessions. We had to draft the initial draft data card. We had to draft, you know, the initial data governance framework and charter and data management SOP. We had to refine that data card, and we had to start creating the data card catalog, the repository for the data, and then form that initial data governance working group. So for large organizations, you know, this is really important, this whole concept of a chief data officer. So this slide does not do any of that justice, but I just want to touch on it because it's so important. But, and I'll also give an example. There was one time I was working, extracting data from a maritime ship, and had diesel generators, and they're asking me, hey, can you build a machine learning model for this, for anomaly detection? I'm like, I don't know. What kind of data do you have? And then they're like, I don't know, what kind of models can you build? And I'm like, so it's a catch-22 every time you integrate with an organization, and you have to start with that exploratory data analysis. So you get the data, and it's going to be in some kind of format, and then you have to manage and massage that data and wrangle that data like Krista talked about. And then you have to look at, okay, so what am I looking at here? Oh, I'm looking at exhaust gas temperatures. I'm looking at barren temperatures. Okay, how many are there? And you start incorporating and using statistics to learn to see if you have any anomalies in there. And you start figuring out how you can actually build an anomaly detector for that data. So that is just one use case, but it just takes that iterative cycle on the data. It takes a long time just to get to the point where you can use it for building a machine learning capability or your AI capability. So I guess the takeaway is it is definitely an agile process, and a lot can be learned from DevOps integrated in with the data. Next slide. So our next step is to really build those machine learning models. And again, it's an iterative approach. So similar to DevOps and data ops approaches, ML ops looks to increase that automation and improve that quality, because you'll take multiple types of frameworks like Caffe or PyTorch, and you'll test your hypothesis using those frameworks, and you'll run it, and you'll do the speed of training. You'll start measuring how fast you can train the models using just a standard CPU. But then you quickly learn, as your maturity gets increased, you'll say, oh, wow, I need to throw this on a GPU accelerator to speed up the training time, because it took me 3 weeks to train on this large batch of data that had a large feature set. Oh, and maybe I can speed up my training time for the model by reducing the complexity and reducing those feature sets. Like, again, back to the main diesel generator I was working on. Did I really need all 2,000 features from the entire engineering room? No, I just needed 57 features that were sensor readings from just one engine to build a model for just one engine. So you reduce the complexity of what you're doing, and then you build a machine learning model on the basic areas that you want to accomplish. So there's some sample use cases, and Krista ran over those, NLP and computer vision. There's so many others. But essentially, these machine learning models are very, very dedicated models that achieve something and do it really well. Something very specific. Next slide.
Well, so before we go to the next slide, I just wanted to add one comment, which is, this is all right, but similar to DevOps, and I know, Brian, I'm sure your community has talked a lot about this, where companies are starting to create software to streamline this process, so you don't have to necessarily build your entire DevOps pipeline from scratch, unless you want to, right? Companies are starting to build MLOps software. So you don't have to build in these structures on your own. You can start to use their environments, and they'll integrate it for you, right? So there's software that can support this process. You don't have to create it from scratch unless that's something you're interested in or something that's required by the project.
Yeah, and I'll add to that. That's a good point. The folks that are taking on the DevSecOps practices, they're including containers and the containerization using things like Kubernetes, and using Kubeflow or OpenShift or these other capabilities or orchestration tools, because I know RPA has orchestrators to manage the bots. But when you start containerizing your capabilities, now you can scale them in the cloud and then create endpoints to scale up for what you need. So there's some automation happening in that area, and it's really incredible to see. I'm watching it, the community just move at a lightning pace to achieve scalability and containerization with ML and AI approaches. Over. Next slide. Okay, so this gets to AI ops and the sustainment cycle to support it, and that's pretty pretty good. So let's start with the upper left-hand corner with use case analysis, and that's where it starts, right? You start, ensuring that you've had your steps previously, and it might be on a cocktail napkin. Hey, I want to create some anomaly detector, or I want to create something. You take that idea and you move it through and start talking to people within the organization that can make it happen, and get the buy-in to actually do this. So you next form your cross-functional team across your organization, whatever your stack looks like. And then you start actually really researching the idea about what frameworks could support it, what equipment you're going to need. Can you use containers? Is there a container that might fit the bill that you could use already? And this goes even back to RPA. Is there a bot available for what I want to do already? And can we go to the bot library and pull it down? And do we have to spend money on that? So there's this little cost analysis too, as well. So then you conduct your AI research, and then you build your prototype. And now the next thing, you want to put this on your infrastructure, and you want to make sure that the infrastructure is scalable, and you might have some hybrid approach between your internal infrastructure versus a cloud capability. And then you want to conduct the next step. You want to get with your data ops folks, and you want to start doing the ingestion of live data and processing. And when you've sort of sorted all that out, now you can deploy your AI capabilities and then start monitoring those AI deployments. And then you're like, wow, after you've gotten to that peak, you're thinking, wow, let's do that again. And now more use cases come in, you've developed your entire workflow, and then you become more and more successful. So if you can hit one out of the park right away, then the organization as a whole sees the benefit, and then game on. So that's the key, and that's what the COEs help to do, is try and get the organizations to those level of wins that the organization can see and harness and use. And this is where I'd like to call out, Michael Kratsios and Lynn Parker for their work on the Executive Order 13859 and those pillars that are helping us to advance AI. And I'll just run through those briefly. If you go to ai.gov, you click on that first one, you'll go to the executive order. And the key is we're going to invest in AI research and development, unleash those AI resources, remove barriers to AI innovation, right? And some of those barriers can be just training, right? So we got to train that AI ready workforce. And then lastly, promote an international environment that is supportive to American AI innovation and responsible use. So my hat's off to them and the cadre of folks that have helped them develop that, because it's helping us to integrate AI within a number of different organizations today. And that's all I have. Thanks.
Yeah, so I think we have one more slide. Yeah, so I just wanted to kind of wrap this up and bring it back to, right, we've got our three communities here. We've got our RPA folks, we've got our DevOps folks, and we've got our AI folks. And we've spent a lot of time talking about AI and DevOps, and honestly, RPA plays very well into this environment, right? And especially when we're talking about intelligent automation, right? RPA, I think, Jim, your community has done a really great job of showing, RPA is already showing that if you can get some automation just to some of these basic tasks, that's great. But I know I've worked on RPA projects, and I'm working on an RPA project right now, and there are barriers we're running up against. So let's say the data that you're trying to access in your bot is in a PDF. Well, now we're starting to talk about some artificial intelligence to extract that data. And what if the information you're looking for isn't a clear field? What if it's not date or email address, right? Imagine a situation where people are submitting complaints or claims or requests, and there's a free body of text that says, describe your request. Now all of a sudden RPA isn't going to be able to do a rule-based system, right? You're going to have to start bringing in artificial intelligence as part of your automation process, right? So all of what we discussed here, right, when you're building RPA bots, right, you can start small with your bots, and sometimes a rule-based bot is going to solve your problems, right? Sometimes it's not. Think about this whole process, right? Think about your environment and how you're going to be building it out, really to get to that point of intelligent automation, right? That bot that's going to be supporting the end user, the mission owner, the business owner, to really streamline their processes. So that's all I've got. I'd really like to open it up. Jim, Brian, do you have any comments? And I know I can see the chat blowing up with lots of comments and questions, so I'd love to field those as well.
Absolutely, and Jim, I'll go ahead and MC the questions there, and I'll just work from top to bottom. And Krista and Joe, if we don't get through them all, I'll send a follow-up email to y'all with the questions. But to the audience, yep, if you haven't asked a question yet, feel free to do so, and we'll work through. And the first one is interesting because on the full time I work at login.gov over at 18F, right? And so Stacy is asking about credentialing. How do digital worker credentialing to meet FSMA, NIST, and FIPS requirements? Do you use Active Directory accounts, single sign-on, etc.? Do you require multi-factor authentication, and how do you meet that?
So I'll start with that, and I'm going to start by saying I am not qualified to answer that question.
Okay.
But I will. I'll give you what I have seen, and you're also probably not going to like that answer. The answer is you kind of got to figure out what is it you're trying to do, because I know, Jim, your community, and even in your handbook, you talk about, well, where are you deploying these bots, right? Are they, and even if it's an intelligent bot, right? Is this just sitting on someone's individual machine? Is this sitting on a VM? Is this like sitting in the cloud? Because that's going to impact how you handle authentication and how you handle who gets to use the bot and how do you make sure who gets access to that, right? So the answer to that, and what I will say, my experience with this has been, is day one when I stepped foot on this project and said, we're going to do RPA and we're going to do some intelligent automation, I said, where's my security team? I need to talk to them first. And they have been involved in this entire process. I can't speak for them, but they have been immensely helpful in helping us figure this out. And sometimes I'll ask a question about this very thing, and they'll say, I don't know, but then they go figure it out, right? And so together, combined with their security expertise and kind of our AI and automation expertise, we're able to figure out what is the right answer to that based on requirements, but also based on what we're trying to do for a client.
For DevOps, do you have a shortened life cycle to obtain and maintain an ATO? Speaking of security, right? Does the system have to go through all the signatories for every change or update? And that's also from Stacy. Clearly, Stacy's interested in the security aspects of it.
Yeah, I'm going to be honest. I don't know the answer to that. It's a great question.
Yeah, Joe?
I'd like to know the answer to that.
Cool.
So it depends. There's some tactics for, are we just talking RPA only, or are we talking machine learning capabilities that are contained in a container? There's a number of different efforts that are being worked for hardware root of trust and then signing certs all the way up into the container. So you have an immutable operating system. And then deploy those at the edge, and how you deploy it also needs to be reconciled. So some capabilities are an endpoint that's created in the cloud or your local infrastructure. Some things are containers, and then you open up as an endpoint using the containers. So it really depends. I've seen with RPA the credentialing being done with an actual PIV card, and the personas based on those bots. So and they have their own persona. So it depends. It depends on the organization. It depends on the level of risk and trust that they want to accept. So, over.
Interesting. Well, our next question is from Jay. Could you describe the difference between using RPA to trigger pipeline versus using Alert or CloudWatch with AWS? That's to Krista or Joe.
Yeah, I think actually probably that's a Jim question.
Well, that's definitely the benefit of RPA, right? Is with orchestration software, you're able to kick off those processes. Although I have to admit as well, I'm not very familiar with Alert, CloudWatch, so I'll need to take that one back, and we'll put something out to the community. Great question, Jay.
Absolutely. From Mike, how important are the standards bodies, NIST, etc.? in evaluating and developing a best practice operations stack for an agency if each situation is unique?
So there, Joe, do you want to go first?
Well, I think NIST is ultra important, right? We use NIST all the time for our standards, and we develop policies around those standards. So like defining AI, so there isn't a good definition. NIST has not created one for the US government. You won't find a definition on artificial intelligence, JP 1 Tech 2. So we take the academic definitions right now, and then we apply them. So it's a work in process right now. So, but I would agree. I would tend to agree those standard bodies are very important right now. That way, each agency and organization can pull from those defining and guiding documents and standards. Over.
Yeah, and so that was going to be my response. The answer is they're important. But what you'll notice is there are not.
Simple answers are always good, right? Yeah.
There aren't AI standards right now. And the answer is because it is hard. And I think the big challenge with artificial intelligence is this is not a solved problem, right? There are many questions that folks are asking that there's not an answer to. And in many cases, we're building this ship as we're flying it, right? Like it's tough. And we look to these standards bodies and they're also asking these very same questions.
Excellent. From Ravi, and Joe, I'm going to pitch this question to you based on the slide you covered. Can you talk more about the challenges of gathering data from multiple sources and the challenges of cleansing the data for use for machine learning? And Krista, you can answer too, but Joe, I know you hit on the data
yeah,
one.
I'd rather have Krista answer that one.
Oh,
but,
Krista, go ahead then.
Yeah, Krista, go.
So pulling together data from disparate sources is far and away the most annoying part of doing this. It is also the most time consuming and the hardest, because it's not just a technology problem, right? If it were, the technology part of it is hard, right? If, let's say you have data that exists from a third-party data provider, what does it look like? What format is it in? Is it a bunch of PDFs? Is it a website? Is it JSON? Is it XML? Is it something that somebody invented long ago that is no longer usable, right? What are the other data sources? What is the volume and velocity at which they're coming to you? Do you have some data sources that are coming in every second and some data sources that are stagnant, right? The other side of that is there are people that own these data sources, right? So if you're doing a project using only internal data or touching only internal data systems, you might have your own challenges there. Who owns that data? How are you going to get permission to access it? What's going to be the mechanism that you get it from where it's at now to where you need it, right? And then if you're dealing with third parties, which I would say many challenges are, you've got an added layer, right? Like you've got to go out to who owns that data. Is it going to cost you extra money to get that data, right? So it's a challenge, and it's tedious and annoying, and there is no one right answer for how you do it. What I will say is the way you do it is you get someone who's real charismatic and has got a lot of gumption and is not afraid to call a lot of people and push them.
Very comfortable with the cold calling then, huh?
Yes.
That's a great answer. And then think about all the headquarters that have all the roll-up data that dashboard it, and they want to learn how to use machine learning models to trigger them and trigger reactions or trigger information for them, because even the roll-up data that they're getting is just overwhelming them just to make better decisions at the top level. So, inside just the cyber side is just immense. That's a lot of data coming in that is even pruned down, that even gets sent up to headquarters, and even headquarters is getting all these injects, and they're having a hard time just handling that data. So data is a big issue, like Krista said, and that's why I left it in her court.
Well played. From Peter, would you use a GUI-based RPA when there are documented APIs available versus undocumented GUI elements?
So I think that it's going to depend on what you're trying to build, but REST APIs have become very popular for a reason, right? And like these huge companies have made mandates that they will be API-based companies because interacting with APIs is just so nice, right? It controls data. You get data in a standard format. Any updates or anything like that come through the API. So my personal opinion is use APIs when you can.
Yeah, absolutely. And
Great.
it really is the level and skill of the people that are operating it, because people will get bored with the UI-based one pretty quickly, and they'll want to start learning how to code and do it themselves and create their own scripts, and they want to change things and adjust them without having to pay the vendor a lot of money to make that change. Or maybe it's not in the budget to do that, so they want to do it on their own. So, and take advantage of some of those APIs and things that are out there already.
And Jim, how about we take one more question? How's that
Sounds
sound?
good.
Yeah, from time perspectives. Here from Eugene. From a DevOps perspective, how is RPA really different than a traditional functional testing automation used in DevOps, such as with Selenium? Is there really a requirement for RPA in the DevOps environment?
Jim, do you want to take that one? I have opinions, but I don't know if there's an official statement you want to make.
I don't have an official statement either. I'm curious. Yeah, go ahead, Krista.
Yeah, Krista, share your opinion. Asterisk, it's her opinion.
I get it too.
This is Krista's thought on this, because I've had this conversation, right? When you've got kind of a software shop, right, or an IT shop that already has a lot of system things going on, right? They've got system entities and system checks and system regulators going on. Why do you need RPA? And my answer to that is, well, if you've got the chops to be able to build a bot, to be able to do that, or sorry, the chops to be able to build some kind of system entity to be able to do that, yeah, do it. I think where RPA is really providing a lot of benefit is, one, in cases where to be able to do that, it is very expensive, or it's very labor intensive, or requires some kind of overhaul of an existing system, which may be a worthy endeavor to pursue. But if you're talking about a 5-year project, that doesn't solve your problem today, right?
Right.
The other thing is, I think RPA adds a lot of value when you're dealing with data that doesn't necessarily exist in a format that's going to be consumable by a program like Selenium, or by something where you could just write a Python script to do all of this, right? Like these interfaces that they've built in these companies that are able to build these bots, they've got like a pretty slick system where you can say, just give me your Excel file, give me the link to your website, give me your API endpoint that you want to hit and your key, and they just like boom, 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 like put them right in order, right? So I think the real answer to that is like, how big of a lift do you want to make here? Because if it's a big lift, RPA might be a really good in between solution to overhauling your whole system. Those are my opinions. Like, please push back, disagree, tell me I'm wrong. I'm welcome that.
No, Krista, thanks for that. And thank you both, Joe and Krista, for presenting and sharing your thoughts. Also, thanks to the audience for your energy and the Q&A. We didn't get to all the questions, but there's just a few we'll follow up with Krista and Joe to get answers out, and we'll kick those answers out through the listserv and or Slack channels. Otherwise, there was a lot of interest in a follow-up related to security team. Jim and I are going to take action on that, see if anybody answers the call. But one last call to the audience. We've had 3 participants, 3 wonderful presentations, GSA, USDA, and NASA. Anyone else have something to share? Again, this is about learning. Speaking of machine learning, this is about organizational learning and folks bravely applying best practices out of industry and new methods in government. As Joe was describing, we're inundated with data. There's so many challenges, right? And this helps mitigate some of those. So anywho, if you all have anything you'd like to share, feel free to reach out to Jim or I, and we'll tee up another session. It'd be wonderful to make this a series, third of 4, so, a series 3 or 4. But if not, it was wonderful having you all. This is really all just based on market need and opportunity. So feel free to reach out to us. I'm going to put my email address in the chat window there. Otherwise, Krista and Joe, thank you again so much. Jim, anything else in closing, sir?
You covered it well. Yeah, look forward to continuing the dialogue, and thanks again to Krista and Joe.
Thanks, everyone.
Thank you all. And
Yeah.
I just dropped my email address if anybody wants to tee themselves up for another joint event with RPA, AI, and DevOps. So Joe, Krista, thank you again. Appreciate it.
Thank you.
Great day.
Yep. Bye.
Take care, everyone.